Hello, Algebra 2A, and welcome to Lesson 38, Day 1, where we are going to work on a 3-day lesson of talking about dividing polynomials using long division. And before we get into polynomials, we're going to review how numbers work when doing long division. And then you're going to find out that the long division process for polynomials is identical to how we long divide numbers. So first, we'll talk about a couple of things about a division problem. First, the divisor. Divisor is the number that which another number is divided by. So here 5, this would be our divisor. As we look at our polynomials, we'll be dividing by divisors that are monomials. They only have one term. Or we'll be dividing using binomials, which are polynomials that have two terms. Next, I'm going to go to the dividend. The dividend is the number that's being divided. So here is our dividend. So our dividend is the number that is underneath the house per se, and that's the number that we are dividing. Now we're going to get into the process of how we do long division. So we have this 5 out here. We check first how many times does 5 go into 2. It doesn't go into 2. So we move to our next piece. How many times does 5 go into 24? That's going to go in 4 times to make 20. Then we do our subtraction. We get 4. And then we complete our first cycle. So in our long division process, we're taking our dividend and we're looking at how many times does it go into the 2, which it doesn't work. So then we look at how many times does it go into 4. It goes 24. It goes in 4 times. Then once we complete our first cycle, we'll drop down our next number, 43. Now how many times does 5 go into 43? It goes in 8 times to make 40. And then we subtract and we get 3. So we've got a couple other things happening now. 48. 48 is our answer. That is called your quotient. So your quotient is the answer to a division problem. And the 3, anything left over, that is called your remainder. And then when we're doing polynomials, that's going to be a big piece of what we're looking for, is just checking out what is the remainder to see if we have a factor. So we'll talk about that when we get into Day 2 and Day 3 of Lesson 38. So there's kind of a brief rundown of how you do long division. Now we're going to start heading into problems like example 1 and start to do a long division with polynomials. To start our polynomial long division, we'll start by putting the divisor on the outside of our house and then the dividend on the inside. So I can tell we're dividing this polynomial by 8x. So you're going to want to go ahead and pause the video right here, and you can write out your polynomial division. When we do our long division, we are going to start building our quotient up above our dividend over here. In this case, I have one single term that I'm dividing by, so this would be considered a monomial. Sometimes I'll have binomials, and we'll look at that when we get into example 2. But what you're trying to do is you're trying to take this term and think about what could you multiply 8x by to get it to match exactly the first term of this polynomial. So again, you're trying to get 8x to match perfectly to 32x to the 4th. Now with the numbers, that can be pretty easy because 8 times 4 would equal 32. So that tells me then that the number part has to be a 4. But then I look at the x. How could I make x, multiply it by something to make it x to the 4th? Well, that would be x to the 3rd. So I got 4x to the 3rd times 8x. That's going to match up to make exactly 32x to the 4th. So it's a little different than long division where you're just trying to get as close as you can to the number. In polynomial division, we're trying to match exactly that first term. And our problems that we deal with will work out to do that just fine. Then we do our subtraction. That's going to subtract to make 0. So we drop down our next term, which will bring down the negative 104x to the 3rd. Next, I'll look at how could I multiply 8x to get to negative 104x to the third. Well, that's going to be a negative 13 because negative 13 times 8 is negative 104, and then an x squared. Now, something you'll notice as you're building your quotient up here is you're just going to start counting down by 1 degree. And really, then you're just kind of dealing with the numbers. How can I get 8 to get to negative 104, which was negative 13? Well, then we'll get our negative 104x to the third. Anytime I have a negative, I like to put in parentheses, subtract it. It's going to make 0. We bring down our next term, which is 56x squared. And multiply 8 to get to 56. That's going to be a plus 7 because 7 times 8 is 56. And then multiply x to get to x squared. That would be an x. So 7x times 8x is going to be 56x squared. And subtract that out. We'll get that to be 0. Bring down our next 8x. And what could I multiply 8x by to get to 8x? That's going to be 1. 1 times 8x is exactly 8x. Oops, 8x. Subtract that out. Bring down our 4. Now we get to this point where 8x will not go into 4 because 8x is a higher degree. So we're left with our remainder of 4, which when we write a remainder, we're going to add on a 4 over the divisor. So 4 over 8x would be my final term. So since I don't have I don't have an x to go into 4, 4 becomes my remainder. So that would be my final result. So there we did our first long division. 4x to the third minus 13x squared plus 7x plus 1 plus 4 over 8x. We'll finish up today looking at one example of long division that has a binomial. So we'll start out by first writing out x plus 7 would be our divisor, and then the polynomial will be our dividend. So next we'll look at 3x to the fourth plus 11x to the third, and so on, dividing by x plus 7. So x plus 7 will be our divisor, and then the polynomial will be our dividend. So go ahead and write out your division problem. You may want to pause the video here so you have time to write that out. All right, now we're going to look at our first time when we're dealing with a binomial. So we're going to use the same type of idea where we're trying to match this first term to start building our quotient. Whenever we have a binomial, we're only focused on this first term of it. So we're always thinking in our heads, how could I multiply this first term to match exactly 3x to the fourth? And then, since it is a binomial, when we start to do our multiplication, we are going to have to use the distributive property and multiply both terms. And then we'll start to get binomials and have to do a subtraction, which we will cancel out this first term, which is what our goal is, and then everything else will just kind of fall into place. We'll do our subtraction, we'll do our next cycle, and it'll just all start falling into place. But first, I'm trying to get x, the x to multiply exactly to 3x to the fourth, and that's going to be a 3x to the third. So that would multiply to 3x to the fourth. I'm also going to take that 3x to the third and multiply it by 7 because I have to use the distributive property, multiply both terms. So that's going to be 21x to the third. And then I subtract. 3x to the fourth minus 3x to the fourth is going to be 0. 11 minus 21. And you're going to find out, since everything is lining up with the same degrees, all you're doing is working with the numbers. 11 minus 21 is negative 10 x to the third. And just like our long division, we're going to bring down that next term of the polynomial, which is negative 55x squared. Now, don't lose sight of what we're trying to do. We're just trying to get x now to match to negative 10x to the third. The 55x squared, we'll just let that be, and then as we do our subtracting, we'll get a new term to try to help divide as well. So how can I get x to multiply to negative 10x to the third? That would be a negative 10x squared. So multiply negative 10x squared times x, that's going to give me negative 10x to the third. Then I multiply negative 10x squared times 7, which is negative 70x squared. And I do my subtraction. Now, every single time, you're always trying to cancel out that leading part, so that negative 10x to the third is going to cancel out. Here, you got to be a little careful. Negative 55 plus 70 is going to be 15x squared. Drop down my next term, which is 113x. Now, how could I multiply x to get to 15x squared? That's going to be a 15x. That's going to give me 15x squared. And then 15 times 7 is going to give me 105. Okay, subtract that out. We're going to get 8x. Bring down my next term, plus 79. Lastly, then, how could I multiply x to get to 8x? I would multiply it by 8, and then that's going to give me 8x. Multiply 8 times 7, that's going to give me 56. And then we do our subtracting, and we're left with 23. So that last piece, I cannot get x plus 7 into 23, so that becomes my remainder. So I put 23 over x plus 7. So there we have it. We've got our 3x to the third minus 10x squared plus 15x plus 8 plus 23 over x plus 7. So we will now head over to Delta Math, take a look at an example of a problem so that you can kind of see how Delta Math will apply these problems as well. But the notes for day 1, that is complete. And then we'll head to Delta Math right now. So here would be an example of a Delta Math problem, and I'm going to go ahead and write that out so you can pause the video and I'll have it written out. So we again are only focused on the 4x. So how could I get 4x to make 8x to the third? That's going to be a 2x squared. So then I would take 2x squared times 4x, and that equals exactly 8x to the third. So that's our vision every time, is how can I cancel out this first term? Everything else will fall into place. Next, I'm going to have a 2x squared times 1, which is going to be plus 2x squared. Then I just always put this into parentheses, subtract it. Those cancel. 14 minus 2 is 12x squared. And then we have still a plus 11x coming down for our next cycle. Now, how could I multiply 4x to get to 12x squared? That would be a 3x. So then I'm left with 4x times 3x, which gives me that 12x squared, which is what I wanted. And then 3x times 1 gives me that 3x. Again, parentheses, subtract. And we get the 12x squareds to cancel out. We're left with 8x. And then bring down my plus 2. Okay, what could I do to multiply 4x to get to 8x? I would multiply that by 2. 2 times 4x is 8x. And 2 times 1 is 2. And here we get our first remainder of 0. So today we're assigning just level 1, and all level 1 problems will have a remainder of 0. So we just head into our answer, and we're putting in the quotient. So it'd be 2x squared plus 3x plus 2. All of those will be remainder of 0, so you don't have to worry about putting in any remainder. And then they will also walk through the problem with you. So even if you get it right, it's a good idea to check it out. Make sure that you're doing the same steps that they are. So that'll be it for day 1. Delta Math assignment is ready to go, and you can go ahead and get started. And good luck.